Okay, so this lesson is called Visualizing the Water Cycle, and the goal here is to help students think about the water on Earth, that it's a resource that we need to take care of, and that it's a resource that is continually cycling through living and non-living parts of the Earth. And so it's a very, very big system within the global system, but it's very connected to all other systems. So sometimes in earth science, we like to say that everything is connected to everything else. And so when we think about the water cycle, it's obviously very, very connected to the cycle of living things. It's connected to the geological cycles of the Earth. And this lesson is going to focus on the very simplest, just basically the simple water cycle: evaporation, condensation, precipitation. But we're going to help kids think about some of the things that might happen along the way, including what happens when we get pollution in our water, how much filtering can this natural cycling process really do, and we're also going to talk about sort of how the water that you are drinking today easily could have been dinosaur urine, a few million years ago, because it's the same water, the same H2O, just cycling and continuing to cycle throughout the Earth's history. So we'll start with a demonstration, and I'll stop and show you that right now. This is a little demonstration you can do with your students to kind of show them the distribution of water on the planet. And so if you start with 1,000 milliliters of water, you take about 28 milliliters of that and you separate it off. Okay. And so then the remaining 982 milliliters is salt. Right? Salt water. And that's actually 972 if you do the math right. So this, we're going to put red food coloring in because this is salt water found in the oceans. Right? You're not going to drink that. Stir that around. So this 28 milliliters is our fresh water. Okay? So we'll put a couple of blue drops in that. And there we go. Okay, so we have this much fresh water and this much salt water on Earth, relatively speaking. And what we're going to do, okay, is we are going to divide this into its respective different amounts. So of this fresh water, right, 23 milliliters of it, almost all of it, is frozen in glaciers and ice caps and snow. Okay? So that takes up almost all of it. Almost all the fresh water is frozen. And of the water we have remaining, about 4 milliliters is in the groundwater, and about 2 drops, 1, 2, this 2 drops represents the amount of fresh surface water in the world. Not very much, obviously. And so this helps students, I think about the vast quantity of water on Earth, and think about how little of it is actually groundwater and fresh surface water that's actually usable for us to drink. Alright, so you can see that really the amount of fresh water on Earth is very minimal compared to the amount of salt water, and especially when we just think about the groundwater and the fresh surface water. It's a very limited resource, and if you follow the news at all, you know that water shortage is an issue that's going to continue to come up and continue to be litigated between states and probably someday between neighbors. So it's important to get kids thinking about water and the cycle and how we can protect our water supply. So the lesson today is going to have students, the activity today rather, is going to have students making a system to try to filter some extremely polluted water. And so it's going to be up to you to make this polluted water, and what I've added to mine is dirt and some pieces of paper and some red food coloring. I've had teachers add oil before also. It's great if you're willing to deal with the mess of having oil involved in this process. When you spill water, even with food coloring, it's not nearly the mess that oil makes. But if you want to add oil to yours, that'd be kind of an interesting mix too. I always give kids the base materials of cotton balls and a paper towel, And then I let them go outside and collect the materials that they would want to use: rocks, gravel, leaves, whatever they think might make for really good filtering. And of course, the students that do the best are the ones that slow the water down the most. The longer it takes this water to get from the top of the filter into the collection container below, the better. And you can see they're going to be using 20-ounce bottles again, just cut in half, where this is going to be the filtration column, this is going to be the collection area. So I'll just make a really simple one quickly. I'll just put some cotton balls in here, throw a few rocks in, some more cotton balls, and then I'll just fold my paper towel on the top and make kind of a collection here. Now you have to remind kids that there has to be a place for the water to go, otherwise they're going to make a mounded filter, and that just doesn't work. So once they get their filter made, it's really simple. You're just going to kind of stir up the polluted water and dump some in their filter. Okay, and we'll just watch and have the students watch and see what happens. And at the end, after we've done the whole class, it's easy to just take the filters out, line up all the filtration collection areas, the collection bottom part, and see how did they compare. You know, how much did they filter out? And I can guarantee that no matter what the students do, they won't filter out the food coloring. And that gives us a really good way to talk about the different types of pollution that are out there in the world. And that the soil is a fantastic filtering mechanism. As the water goes from the groundwater or as it goes from surface water into the groundwater, a process called infiltration, it gets filtered naturally by bacteria in the soil, by the soil itself, by the clay that's in the soil and the little rocks. And that does a really good job, but it cannot filter out all chemicals. And so we end up with things like high nitrates in our wells because of all of the nitrogen that's been put on the soil for so long, and eventually it gets down into our groundwater. So we'll finish with a discussion about that, how there are some types of pollution that the ground does not filter out as well as others. And some really good ways that you can extend this lesson, just thinking about the water cycle, is that you could have students write a story from the perspective of a water drop. This is an idea I got during my grad work, actually, and I don't remember exactly which lab or system class it was for, but one class we were encouraged to write a story from the perspective of a water droplet, and you can name the water droplet and have it, you know, floating around with its friends in the water. It gets heated up, it moves around, it goes up into the sky, comes back down, and it can have some crazy adventures. Which it's a really good way to let students with a creative bend to sort of show off their creative abilities while also showing that they understand the water cycle itself. And again, you know, as with all of these things, the more times you let them try this filtering process, the better. Make a giant classroom filter. Take a Brita filter pitcher and take it apart. What's going on in there? What are we missing that they have? So you can do a lot of interesting things with the filtration part and with the water cycle part. And this is just a lesson to try to get kids thinking about how water has cycled since the beginning of time and how it will continue to cycle because of these processes of evaporation, precipitation, and condensation, and also infiltration into the groundwater system. So this is another fun one, and I hope you and your students have fun with it. It's another one where it can get a little messy, so you may want to have some towels ready to go. But I think it'll be a lot of fun, and the students will really start to understand this process of infiltration and how it fits into the water cycle. So we'll see you next time. So one other thing that I sent along that you can do as an extension is you can create a solar still with your students. You know, you take the polluted water, put it in the bottom of this container, put a smaller container in the inside, put a rock right above that smaller container so that the lowest point of this saran wrap is right above the container. And you set this out in the sun on a hot day, and this smaller container will fill up with essentially clean, pure water. It'll actually will leave the food coloring behind. And so this would be a way to get pure water from this polluted water. So that's another way to talk about evaporation as sort of a filtration method in itself.